Hello guys, welcome to the last lesson of proportion. We already learned how to use similar figures and set up proportions to find indirect measurements. And this time we are going to use proportions during scale. Okay, vocabulary for today are scale drawing, scale factor, scale model, and scale. Now remember when we were dealing with the similar figures in the last lesson, and when we reduce their corresponding sides, the corresponding sides are proportional, we usually end up with a number. Now that number is what is called a scale factor. Now one thing you need to keep in mind is that if the scale factor is less than 1, that means the the object was reduced. And if it is more than 1, it was enlarged. Okay, so if the scale factor is less than 1, for example, where we end up with a fraction, then it will be that means the object was reduced. That means we're going from a larger object to a smaller object. And if the factor is more than 1, that means it was enlarged. That means we're going from a smaller object to a bigger model or model drawing. All right, let's keep going. Now, a scale drawing is a proportional two-dimensional object. All you have to remember is that a scale drawing is representing it's a 2D image. For example, a a floor plan would be a 2D. A blueprint will be a 2D. So that those guys will be called scale drawing. Now, scale model will be 3D shape. Okay, and then the scale is almost the same factor, is the same as scale factor. That's the number that was used to either reduce or enlarge the objects. Now the scale can measure the same units, or it can measure different units. For example, on a map you can see that 1 inch on a map represent 3 yards in actual life, or 1 inch on the map represent actually 3 miles in real life. So again, we can be comparing the same units or different units. All right, so let's go ahead and try this problem. So we need to identify the scale factor here. So here we have a room. Now the actual length of the room is 144, and someone did a blueprint where the length of the room was only 18 inches. And then the width of the actual room was 108 inches. And then on the blueprint, that means on the drawing, on the model drawing, it was only 13.5. Now, one thing you need to keep in mind right here is very important. Please copy this down. Is that the scale factor is always the ratio of the model to actual. Because on an exam, they're not going to tell you, oh, the model was used for that was 1 inches and the actual one was 3 feet. No, no, no. It it's going to tell you, okay, the scale was 1 to 4. So you need to understand that that 1 is for the model, and then the 4 is for the real life. So first thing we want to do is to write a ratio using one of the dimensions. So let's just go ahead and use the length here. Okay, so remember, it's going to be model to actual. Model to actual. Model is always on top. Whatever we are, the second copy, whatever we are recreating is always on top. Okay, and then the actual picture is always at the bottom. So if you see here, we're putting the blueprint, which is my second image, on top, and then the actual room, the physical room, its actual dimensions at the bottom. So please remember, with scale drawing, it's model to actual. Alright, so here it was 18 to 144 inches. And now what we want to do here is to simplify, and this tell me that the scale factor was 1 to 8. What does that mean, 1 to 8? Okay, that means for every 1 inch on the blueprint, it actually represents 8 inches in the real life. Okay, again, for every 1 inch on the blueprint, on the model drawing, it actually represents 8 inches in the real life. And usually this is the reduced scale factor that they will tell you that they used. So then you can use that same scale factor to keep everything else in the room proportional in your drawing. Alright, so here is another example. We need to identify the scale factor. So first thing I'm going to do is to put model to actual. When you do this, you cannot go wrong. Okay, and then here they tell me a model aircraft and then a blueprint. So I know the blueprint is going to be my second copy. So that will be my model. And the model aircraft, that was the actual that we started with. Okay, so again, we can use either one of these. So let's use the wingspan this time. So on the blueprint it was 3 inches, and then in real life it was 18 inches. So you can see that this was a reduction. It was reduced. So our scale factor will be less than 1. So when we reduce these by divide both of them by 3, we will get 1 6. So that means for every 1 inch on the model drawing, it actually represents 6 inches on the real model airplane. Again, model actual. And since this number here, the scale factor is less than 1, when we do 1 divided by 6, we get us the really tiny decimal. That means this was a reduction. Okay. Alright, so go ahead, and here's another example. We have a photograph was enlarged and made into a poster. The poster is 20.5 inches by 36 inches. Now the scale factor is 5 to 1. Find the size of the photograph. Okay, so here I'm going to draw what's happening. They tell me a photograph was enlarged. So that means I'm going to start with a small picture. Okay, and then it was enlarged. Alright, and then they tell me that the poster is 20 by 36. So that's it. This is 20.5 inches by 36 inches. Now I knew it was enlarged. This picture here was enlarged. We need to find the dimension of this one, the small actual photograph, which we do not know. We need to find X here and Y here. We can just label the dimensions since we do not know them. So one thing we can do here is to again always set up. So this was my actual picture and this was the model picture. Remember, this is the one that I started with. Okay, remember it was enlarged, so the smaller one was what we started with, and then we blow it up. So that will be my model. So again, it's always model to actual, and they tell me that the scale factor is 5 to 1. 5 to 1. Again, model to actual. Okay, so let's go ahead and find this the width first. So it was 36 on the model. So if it was 36 on the model, then I can figure out what y is. Okay, and then here we can do 36 times 1, which is 36, and then we divide by 5. Let me bring up my calculator here. Okay, so on the calculator, when we do 36 divided by 5, we get that the width will be 7.2 inches. So this right here was 7.2. Again, quick recap. This was my actual picture, my original picture. Okay, and then we blow it up to make a bigger model. So it will all remember, scale factors always model to actual. Model on top over actual. Now they gave me a scale factor of 5 to 1. So that means for every 5, for every 1 on the actual model, it's actually represent 5 on the model drawing. Okay, so knowing that information, we can go ahead and set up the proportion and figure out what the width is of the actual picture, the original picture. And so this will be 35 to 1 equal to 36, again, which belong to the bigger model, to y, which belong to the little one that we do not know. And then we solve the proportion to be 7.2 inches. All right, let's go ahead and find the length. So again, it's always model to actual, and the scale factor will not change. Still the same, but this time, since we are finding the width and the length here, it will be 20.5 for the model to the actual one, x here, that I do not know. Okay, and then we go ahead and divide 20.5 divide by 5. Okay, and then when we divide, we get 4.1 inch. So that means the smaller picture was actually multiplied by 5 to get the new dimension for the bigger picture. Everything was multiplied by 5. Okay, so if we multiply this by 5, we'll get 36. 4.1 by 5, we'll get 20.5. Okay, any questions? Please post them on Edmodo. Okay, here's another problem. Go ahead and try it out. Come back and get the answer. Okay, all right. Welcome back. So let's go ahead and do this problem together. So here we have Mary's father made her a dollhouse which was modeled after the blueprint of their home. So right here in this sentence, that I know that the dollhouse is my model, and then the blueprint of the home was the original, or the actual picture. So we are modeling the dollhouse after the blueprint of the house. And then it tell me that the blueprint is 24 inches by 45. So let's go ahead and draw that here. Let's say this is 24 by 45. And then the scale factor is 1.5 by 1. Now because the scale factor is 1.5 to 1, and that number is bigger than 1, so I know they made a bigger model. Okay, and we need to find x and y, the dimensions of the dollhouse. Okay, so here we have my model. We can set up the proportion again, model to actual. And in the model, we do not know. Let's go ahead and start for x first. We do not know what x. Let's go ahead and put the factor in, 1.5 to 1. And then x in the model, which we do not know. Remember, this is the dollhouse. and this is the blueprint, which is the actual picture. We do not know what x is, but on the blueprint we do know it's 24. And then when we go ahead and we multiply 1.5 times 24, that will give us the new dimensions for the dollhouse. Let's go ahead and do that. And that will be 36 inches. So x will be 36. So this right here is 36 inches. Now let's go ahead and find the other dimension. Again, using the same ratio, 1.5 to 1. And x will be, this time we're solving for y on the model that we do not know. And this time on the blueprint, on the actual one, it's 45. And let's go ahead and multiply those two. And we get 67.5. Now, this problem could be a little confusing. It is confusing if you do not read. Okay, so you need to read and also draw it out so you do not get confused like I did here. Okay, so the dollhouse was modeled, so that means the dollhouse is the replica of the blueprint. The blueprint is the original. Okay, and then the dollhouse was the model. And then we know the scale factor is always model to actual. We need to know that information in order for us to be able to place the values in the correct space for the proportion. All right, let's go ahead and do another one. Right, here's the dimension. All right, go ahead and try this and then come back and get the answer. All right, welcome back. So here we go on a road map with a scale factor 1.5 inches to 60 miles. The distance between Pittsburgh and Philadelphia measures 7.5 inches. What is the actual distance between the two cities? Now, when we are dealing with map, it's a little easier because we are dealing with different units. So it makes life a little easier and less confusing. So here, let's highlight the most important information. So the scale was for every 1.5 inches, it actually represents 60 miles in real life. And they tell me on the map, they measured 7.5 inches, and we need to find the actual distance in real life. So again, here I'm comparing inches to miles. Now, because they are different units again, I can do this. But again, remember it's model to actual. The inches, which is this on top, the model, and then the miles, which is in the real world, the actual distance. All right, so and then here the scale factor again is 1.5 inches to 60 miles equal to 7.5 inches. Now, where will I put 7.5 inches to set up the proportion correctly? On top. Great. I know you guys were smart. And my x will be down here because I do not know the actual distance, and that is what they want me to find. So let's go ahead and find the cross product here to find x. And we need to do 7.5 times 60, and then divide that by 1.5. And the actual distance in miles will be 300. From Pittsburgh to Philadelphia would be actually 300 miles. But can we really draw 300 miles on a piece of paper? No. So that's why we use scale factor to shrink things down sometimes. Okay. I believe there's one more. Let's see. All right, here's one more. Go ahead and try it and then come back and get the answer. All right, welcome back. Hopefully, you guys getting a hang of it here. Here we are comparing inches to kilometers. So one for every 1 inch on the map actually represent 50 kilometers, and we need to find what does 7 represent. So this is really just 7 times 50. All right, go ahead and try this one. All right, so let's take a look at the answer here. Here again, we are comparing inches to miles. For every half inch is actually 40 miles this time. Again, model, actual. And then we need to figure out what 3 inches is. Inches, inches, miles, miles. And then we find the cross product, which will be 240. Okay, well, that's it. Thank you guys for another wonderful lesson. See you guys in class where we'll really be using the modeling to draw a scale drawing, to do a scale drawing of the class. So please rewind and watch the video. Make sure you understand and post your questions on Edmodo. I'll see you guys in class. Have a good one. Bye bye.